Okay, Year 12, I'm just going to go over the stuff from binomial theorem that we started today. Our work today isn't actually on binomial theorem, it's more on combinations, which will lead us into binomial theorem. The main thing that we need to know is how binomial theorem, or Pascal's triangle, will relate. And we'll see that pretty swiftly. So Blaise Pascal was the person who was attributed with inventing Pascal's triangle, and it relates very nicely with the expansion of binomial products. So for example, if I had 1 plus x squared, that's a terrible 2, squared, I know that that expands to 1 plus 2 times 1 times x, so 2x, plus 1x squared. And you want to probably thinking, why did you write the 1? Well, if I look over here, I can see a 1, a 2, and a 1, and a 1, a 2, and a 1. Now this repeats itself as we go along. If we were to look at 1 plus x all cubed, and I'm not going to do it, but we would get 1. And then we would get 3x, because we've got to have an x0, an x1, an x2, and an x3. They're going to be our terms. So we get a 3x1, there's an x0 there if you want to have it, but you don't need it. Then we get another 3x squared, and then we get an x cubed, a 1x cubed. And as you can see, we get a 1, 3, 3, 1. And this goes on. You can see 4. If I did 4, 1 plus x to the 4, I would get 1 plus 4x plus 6x squared plus 4x cubed plus x to the 4. And that works out really well. But the very neat thing is that these things now correlate with our combinations. So this is 3c0. This can be got by getting 3c1. This can be got by getting 3c2. And this can be gained by going 3c3. The same way here, this will give us 4c0, 4c1, 4c2, 4c3, and the 1 that's there is 4c4. So you don't need to write all of Pascal's triangle out. You can just use combination notation. Now we're going to learn that later, but the reason why I explained it then is because we're going to be working with combination notation. So the first things you need to know, particularly if you're away, is to know that what n factorial is. You need to know 0 factorial equals 1, and there's a very good number file explanation of that on the website. You need to know that, which is the definition for a combination. Now, don't worry too much about permutations. If you were interested, a permutation, the definition for a permutation, NPR, is n factorial over n minus r factorial. So, for example, I won't use 3, I'll use 5p3, well that's 5 factorial over 5 minus 3 factorial, which equals 5 factorial over 2 factorial. Now that's permutation. Now we don't want permutation. I'm just going over old ground so that you remember what we're talking about. And combinations, the definition is there. But what I think you should write in your notes is that NCR can be written in this way, N double bracket or parentheses R, and that means N factorial over N minus R factorial times R factorial. And the work that we did today relies on you understanding that and knowing another couple of key things is that if you have k plus 1 factorial, that equals k plus 1 times k factorial. You can rewrite it that way. And if that confuses you, think about 7 factorial. Well, that's the same as 7 times 6 factorial. And the same way, you can write k factorial as k times 1 less factorial. It's the same thing. And I'm going to be using this to help me deal with some of the questions that we do in exercise 10.1. There are some other ones that you need to know. And the first one is this, that the leading one, NCN, is 1, and the N1 is 1. If you look back at Pascal's triangle, you see all the ones down this side and all the ones down that side. Well, they're the beginning ones. So NC0 and NCN. Here they are. 3C0 and 3C3. 4C0 and 4C4. They equal 1. So you need to know NC0 equals 1 and NCN equals 1. And finally, there's a symmetry. NCK equals NCN minus K. And as an example, that would be 7C4 equals 7C3. Or if you wanted to say 7C7 minus 4, which is 7C3. The two numbers have to add up to the number at the top. And that's the symmetry, which you can see in Pascal's triangle. 1, 1, 1, 1, 2, 1, 1, 3, 3, 1. See the symmetry here? The 3 and the 3. And if you went the next one, 1, 4, 6, 4, 1, you get the 4 and the 4. And you get that symmetry throughout. So, on to some questions. Now, the first couple are calculator questions, question 1 and 2. I did question 3, 4 and 5 on the board. I am going to do 3J here for the people who weren't here, and then I'm going to do some other ones. So 3J, I'm going to use a bit of space because I'm going to need a bit of space here. 3J, and it was shown 7, 3 equals 6, 2 plus 6, 3. Now, when you're doing a show, you have to show that the left-hand side equals the right-hand side. Now, the best way, I believe, is to take the more complicated side and make it simpler. So I'm going to take the left-hand side and I'm going to go back to my original definition. Now remember, my original definition is NR equals N factorial over N minus R factorial. So 6, 2 becomes 6 factorial over 6 minus 2 factorial, plus here 6, 3 is 6 factorial over 6 minus 3 factorial. Okay, so if I tidy up both of those, I get my 6 factorial. And 6 minus 2, I get 4 factorial. And 2 factorial. And here I get 6 factorial, and 3 factorial, 3 factorial. Now these are two fractions and I want a common denominator. Now I could just multiply both sides by the 4 factorial and the 2 factorial, but if I'm a bit smarter, I can write things a bit differently to find the lowest common denominator. I'm going to take that 4 out of that. I'm going to write that as 4 times 3 factorial. Remember we talked about that? That 4 factorial is 4 times 3 factorial. That's all I've done. I'm going to leave the 2 factorial alone. I'm going to leave myself a bit of space because I'm going to do something in red in a minute. Now here I've got my 6 factorial. I'm going to leave that 3 factorial there. But this 3 factorial, I'm going to write it as 3 times 2 factorial. Now, if you look closely here, I'm just going to get rid of that green bit there. I've got a 3 factorial and a 2 factorial. I've got a 3 factorial and a 2 factorial. So to make these completely the same, what I'm going to do is I'm going to multiply both of these by a single number. So here, I'm going to multiply by this 3 over here. So I'm going to times that by 3. And here, I'm going to multiply this one by 4. And that's going to give me a common denominator. Now look at the denominators and make sure they're the same. 4 times 3 factorial times 2 factorial. 4 times 3 factorial times 2 factorial. Yes, the denominators are exactly the same. So let's just write the denominators down the bottom here because we're writing as one fraction. 4 times 3 factorial times 3 times 2 factorial. That's the denominator. Just check in your head and see that that's exactly the same. On the top, well, here I get 3 lots of 6 factorial and I get 4 lots of 6 factorial. Let's tidy up the bottom again. Well, that gives me 4 factorial times 3 factorial. Just look at that and make sure you understand that that's what those two are. 4 factorial and 3 factorial. Okay. Now let's look at the top. I've got 3 of 6 factorial plus 4 of 6 factorial. Well, that gives me 7 lots of 6 factorial. I've got 4 of something and 3 of something, and I add them together. That gives me 7 of something. Okay, the top's really easy now. I've got 7 factorial, which is what I want to make it look like. Remember, I want to make it look like 7, 3. Well, I can write 4 factorial if I go 7 minus 3 factorial. Is 7 minus 3 4? Yes, it is. And I've got my 3 factorial. Oh, and that is my 7C3, or as they want it, 7,3, which is what we had to prove. Now, I know that's pretty laborious, but you need to go through it and get used to dealing with factorials and rearranging. It comes up in induction. So question 3 is a lot like that. And we did 3A, F and J. I've done 3J for you there. Question 4 is doing exactly the same thing, but in question 4, it's doing it with letters. So we're going to show NK equals N minus K. So when it becomes algebra, it becomes a bit harder. So I'm just going to take the right-hand side. Oh, by the way, I should have finished that off and said it equals the left-hand side. So the right-hand side equals N factorial N minus K factorial, it's our definition, times n minus k factorial. It's our definition. Well, n factorial, bottom here I get n minus k plus k factorial, n minus k factorial, which gives me n factorial, k factorial, n minus k factorial, and that, by our definition, is n k. So that equals our left-hand side. So question 4 is like that. Question 5, 6, and 7 are pretty easy. Question 8 is reasonably